We now find acceleration due to gravity. Let this circle represents Earth. Earth can be treated as a solid sphere. Now let G is universal gravitational constant, me is mass of Earth. Let us consider a point mass m on the surface of Earth. This is at the point P we have considered a point mass m. So this is radius of Earth, RE is radius of Earth. Now this point mass m is on the surface of the Earth. Therefore Earth exerts a gravitational force on P. So the gravitational force with which Earth attracts this point mass m is G, mass of Earth, mass of this particle divided by radius of Earth square. Now because of this force it produces an acceleration. So we know that since this acceleration is produced because of the gravitational force, let us represent it by G. This is the acceleration due to this force. So equating equation 1 and 2, G mass of Earth, mass of the particle by RE square. So this is acceleration due to gravity on the surface of Earth. Now though from this equation we find that it appears that the acceleration due to gravity is same at everywhere, but we will find that acceleration due to gravity changes along with the height, altitude. It changes along with the depth, and it varies also along with the latitude. So we will analyze one by one. First of all, let us analyze how acceleration due to gravity changes with height. Let us imagine a point mass m at P at a height h above the surface of Earth. This is the center of Earth. This distance is radius of Earth. Now let g dash be the acceleration due to gravity at the point P because of this Earth gravitational force. So we find that force on this particle P at of mass m will be equal to G mass of Earth. Mass of Earth is me, mass of this particle by square of distance, that is RE plus h square. Let g dash be the acceleration, therefore then m into g dash equal to this thing, g me m by RE plus h whole square. This cancel out, so therefore g dash equal to gme. We can take out RE square common here, so this expression becomes 1 plus h by RE. So this is the acceleration due to gravity on the surface of Earth. So we can write g dash equal to g 1 plus h by RE to the power minus 2. Now h by RE, this is h, and radius of Earth is 64,000 kilometers, very huge. So this term is very small. So we know that in binomial expansion 1 plus x to the power n can be written as 1 plus nx, and we can neglect the higher terms. So in this equation, if we neglect the higher terms, g dash equal to g 1 minus 2h by re. So from this equation we find as the h increases, so g dash, the value of g dash will decrease. So as the height above the surface of earth increases, acceleration due to gravity decreases. This is the variation. This equation states the variation of g with altitude, that is with height. Now we will derive how acceleration due to gravity changes with depth. Now we will find how the acceleration due to gravity inside earth. So let us imagine this a point P inside the earth, that this is the distance a. So we have to find out the gravitational force at this point P because of this inner solid sphere, and we also know that inside the sphere intensity is 0. So because of this outer part, because of this part, the total force exerted by this at this point P on this mass will be 0. Only the inner solid sphere will be effective in exerting gravitational force, in producing acceleration. So that is, if rho e is the density of earth, it is g, and that is mass per volume 4 by 3 pi r cube re cube, that is me 3 me by 4 pi re cube. So this, from equation number 3 we find that g, that is acceleration due to gravity on the surface of earth, g by re square. me is 4 pi re cube by 3 rho e. This re square cancel out with this, that is 4 pi g re, this is the density rho e by 3. So therefore, because of this inner solid sphere, what will be the force? Let it be F dash. This F dash produces acceleration g dash. This is equal to gravitational force g, mass of the inner solid sphere. Mass is volume into density. Volume is 4 by 3 pi, and this radius of this is pi, and then this pi a cube, this is the volume, into density. Density of earth is rho e, gmem, mass of this by radius of the inner solid sphere square. So let us cancel out this. This becomes equal to 4 pi g by 3 rho e a m. Now we have considered this point mass at a depth h below the surface of earth. So a can be substituted by 4 by 3 pi g rho e. A is radius of earth minus h into m. So g dash equal to this, m and m cancel out, equal to 4 by 3 pi g rho e. Let us take out radius common, 1 minus h by re. Now this 4 pi g re rho e by 3. This is nothing but acceleration due to gravity on the surface of Earth. So g dash become equal to g 1 minus h by re. Thus we conclude, as we go below the surface of Earth, as the h increases, acceleration due to gravity also decreases. So this is how acceleration due to gravity changes with depth. Now we will analyze how acceleration due to gravity changes with latitude.